Pythagoras theorem in 3D geometry. Here we are in a room, and the room is in 3D shape. Now suppose you would like to determine the distance from that corner over the sailing board to the distance at the bottom corner on the floor there. In order to estimate that length, you need to get the idea of the width of this classroom. I mean this room, beginning from that corner there up to this corner. And you need also to know about the length of this room up to this corner. And then that is when you can apply the Pythagoras theorem by using right triangles to find the distance. Now, a sketched diagram for the shape of the room will be this way. This is actually a 3D shape reflecting the shape of the room. This will be the floor, and this will be part of the ceiling. And suppose you wanted to find this distance from this corner to this corner. Now, suppose the width of the room is 10, maybe feet, and the length of the room is 15 feet. And suppose the height of the room is maybe 8 feet. You want the Pythagoras to work in 3D shape to obtain this distance here. You should have to get the idea of the distance from this corner of the room to this corner, so that together this line here and this line and this height here will contribute to make a right triangle on which you can apply the Pythagoras theorem. Now, remember, this height here is known. It is 8 feet. We don't have this distance, and we don't have this distance. So, if you label the corner points of this room as A, B, C, D, E, F, G, and H, you may need to find this distance, so that you will apply this distance and this distance in this right triangle to find this distance here. So if you sketch this triangle here, it will be right triangle, which will be like this. This angle is this point H, and this angle is named as A, and this is F. The height is 8 feet. We don't have this distance here. We don't have it. So it is unknown, and this is unknown. But we can find this distance HF by using this triangle here, which should be this way. Triangle EHF. EHF. Obviously, this angle is 90 degrees. The way this room is, all angles at the corner are 90-degree angles. So this angle is 90 degrees. This is known, it is 15 feet, and the width is 10 feet. So we need to find HF. How do we find it? Apply the Pythagoras. That is 10 square plus 15 square equals to HF square. This is 100 plus 225 equals to HF square. So going on, you are going to have 1, that is 325, and those are feet square equals to hf square. So if you want to simplify, you square both sides, you end up getting 325 feet square equals to hf. So you have hf now. Coming back here, it means this distance hf is 325 square feet. Now we may again apply the Pythagoras theorem to get now AH, the distance that we wanted from the top corner on the sailing board to the bottom corner on the floor. So in this case, applying the Pythagoras here, you will have AH square plus HF square equals to AF square. The sum of squares of the adjacent sides equals to the square of the hypotenuse. So this is 8 square plus HF that we found to be 325 square, and then we square it, equals to AF square. This gives you 64 plus, this obviously will cancel, you have 325 and you will have AF square here. If you add, you'll have 9 and then 8, that is 389 equals to AF. So you square both sides, you end up getting AF equals to 329 feet. I meant to 389 square feet.